Let's take a look at another example of functions that use return statements. So we'll take something that we may commonly want to use here. What we'll do is we'll have a couple variables, x and y. So we'll be doing something a little bit algebra-like, and we're going to make another one. This is going to represent the volume of a cube. So what we're going to do is we will prompt the user to enter the height of a cube. So enter the height of the cube. What we'll do is we'll have that as x. So what we would do is we want to calculate what cube volume is. And we would do this typically by x times x times x, because it's a cube, so the height is all three dimensions. So we would calculate its volume like this. However, what I want to do is I want to write a function that will calculate the cube of whatever number I send it. So what I want to do is I want to do it like this: cube of x. So that what's going to happen is x will get sent to cube of. It'll do the calculation, and then it will return that to the main program. So now let's go up to the top here, and we're going to write this function now. The type of the function, again, is always the type of information that it's returning. So I'm going to be receiving an integer from the main program. If that's the case, there's no way I can have a decimal result on this. So I'm going to have this as an integer. So integer cube of, we'll do int x. And then what we're going to do is we'll write this one just a little bit differently. Don't code this because I'm going to be deleting it in a second. So if I make one called variable called cubed, cubed is going to be equal to x times x times x, and then we will return cubed. So this works totally fine, and this is similar to what I've done in the past. But if you want, you can shortcut this a little bit. So what I want to do is I'm actually going to return x times x times x. So it's going to actually calculate what x cubed is in the return statement line, just like if you were to like see out x times x times x, and then you would be looking at the result. And just to clean this up a little bit, I'm gonna always, usually keep this in parentheses. So anyway, so what it's going to do is it's going to return x times x times x, and then what we're going to do is we'll print it here. So cout the volume is, and this will be cube volume, and okay, so let's take a look at this. So enter the height of the cube. I'm going to put in 5, and then I get the volume being 125 units. Don't matter, I didn't include them in here. So anyway, next what I'm going to do is I am going to make use of my cube of for something a little bit different. Okay. So what we're going to do here is we're going to make a table of cubed numbers. So what I'm going to do is I'm going to prompt the user for another number. So enter the number of cubed numbers you want to see. and we'll reuse X because we don't really need the original dimensions of this anymore. So I'm just going to reuse X. This is sort of a random variable. So what I want to do is I'm going to make a table of the cubes of various numbers. So the way this is going to work, I'm going to use cube table, and then I'm going to be sending it X so I know how many rows in the table that I am going to have. Okay, so now we'll go up to the top of the program, and what I'm going to do is here, now cube table, it has as its job to display something. So the other clue in terms of the type is look at the use of cube of. Cube of gets used in this assignment operation here. So cube of is going to be placed in here. So whenever you see something like this with an equal sign and then a function, you know that this has a type. When you get something that's just on a line by itself, nearly all of the time it's a void function. So it's just a single line command. So this one's going to be void. So void, and this is going to be cube table. So I'm going to get, I'm going to say n, and I'll put a for loop here. So int I equals 1. 1 seems like a good number to start on in my cube table. And I'll keep going while I is less than or equal to n, which is the amount of cubed numbers that they want to see, and go I++. Whoops. Okay, and then inside here, what I want to do is I'm going to print out cout I. Oh, sorry, I don't want that in quotation. So I cubed is, and I'll break this up onto 2 lines just so that it makes it a little bit more clear. Cout, and I want to do cube of I. Okay, so what's going to happen here is it will say, like on the third time through the loop, 3 cubed is, and then it will use my cube of function here to return a 9 here. So that I'll get 3 cubed is 9, then 4 cubed is 16, and so on and so on. Just a second, I just realized that I was saying squares of numbers, but you get the idea. So now there's something that won't work here when we run it. So I'm going to get my error window handy, and this is a very important, this is why this one's called function order. So watch what happens. I'm going to run the program, and then it says error, cube of was not declared in this scope. So it's referencing this line where I have cube of I, but wait a second, it's right here. There's absolutely no problem with this. So the issue that it's having is it's loading my program 1 line at a time. So first it loads this, and then IOStream activates, and then it formats it with this line, and then it loads the first line of this function, and then the for loop, and then the first cout line, and then it runs this. So it's loading this into the program, but this is where it's having the issue, is it encounters this and says, wait a second, I started at the top, I have not yet seen a function with this name. So what we've got to do is we've got to take this and put it above. So whenever you have a function that is used by another function, the function that is being used has to be above it. So now when it's loading, it's going to load the cube of function. It's going to make the table. I'll run this. And then all of a sudden it has no problem with it, because as it's loading the lines of code, when it encounters this one, it says, oh yeah, I've loaded a function with that name. I'm good to go. So with this one, do 5, and then I'm going to do my table with 5, and then it gives me the first 5 cubed numbers. So what we're going to do is we're just going to do one more example with that. This is a useful function. Sometimes the functions we create in these programs are useful, and then you'll recall them later for something that you're doing and say, oh, I don't have to rewrite this. I already created this. So we're going to create another thing very similar to this. So instead of cubed, we're going to do just a powers. So cout, enter a number. There we go. Cin x. I'll move down a bit here. Cout. Enter its power. Cin y. And then what I want to do is I want to show cout x to the power y is, and I want to write a function for this. So I'm going to call it pow of x comma y. So what pow of is going to do is it's going to take the number x and raise it to the power of y. So here's how we're going to do this. Go up to the top again. And then here we'll write this one. This one will have an integer. So again, notice that I'm using this one a little bit differently. I'm outputting it instead of making it the result or being assigned to this variable. But when you're outputting it, it's not on a line by itself. You're using it as part of something else. So this will have a type. So just like before, this one is going to be int pow of int x, int y. Well, you know what? We'll do maybe int n, just to keep it consistent with some of the other ones. And then I'll go int power. Okay, so now this one I kind of need result, because I've got to do some multiplication here to figure this out. So for int I equals 1, I is less than or equal to power. So we're going to multiply something a number of times equal to the power, I plus plus. And then every time we do this, we're going to do result. It's going to get the value of result times n. And then we're going to return the result. There we go. So I'll run that just to test it out. Oh, I have an error here. This is result, not results. Okay, so I'm going to just go through the first part now. Enter a number, 5. Enter its power, we'll say to the power 3. And we can verify that, yeah, 5 to the power 3 is going to be 125. Now what I also want to do is I'm going to do a powers table, just like I did. So I'm going to do a little copy and paste here. Enter the number of powers that you want to see. So this is going to be y. And then I'm also going to prompt them to enter a number. and that's going to be x. So enter a number, enter the amount of powers that you want to see. Instead of cube table, I'm going to call this one pow table. So in order to get this to work, so in order to get the pow table to work, remember that I have to have it underneath the pow of instead of above it. So the order really does matter significantly. So I've got void pow table int n, let's say int lines. We'll use these. This is going to need a for loop, so for int I equals 1, while I is less than or equal to lines. So every time we go through, we're going to create a line, I plus plus. And then what we're going to do here is cout n to the power of, and we'll say I, and I'll go down to the next line, cout is, and then what we're going to do is we're going to do pow of n, which is the number that we've sent, so it's going to be the same for all of them. And then we're going to be increasing the power every time, so n comma I, and we'll put an end L here. Okay, so running this program, make sure everything works. Okay, looks like, oh yeah, I forgot to put the y here. So pow table is going to receive not only the number, but how many lines it's going to have. Let's try that again. All right, so enter the height of the cube. We've done all this. I want to see 5. Let's do 3 to the power 4. And now we'll do the powers. Oh, sorry, I'm going to do 5. And I want to see 5 powers. There we go. So we get that. So this is another example with some return statements. And the very important thing, of course, is whenever you have a function that uses another function, the function that it uses has to be stated above it in the functions list.